And so now I can put that in. I have x squared plus 4x there. In terms of u, that's u squared minus 4. Well, now I'm in a happier position because I can look for u squared minus 4 for something like that in my table here, and it actually sits down here. So, except for the use of the letter x here instead of u over there, that tells me what I want. So to handle this, what I should use is a trig substitution. And the trig substitution that's suggested is, according to the bottom line, with a equal to 2, so a squared is 4, the suggestion is I should take x, but I'd better not use the letter x anymore. But I don't have the letter x, I have the letter u. I should take u equal to 2 secant, and then some letter I haven't used before, and theta is available. Okay? This is a lookup table process. I see this square root of u squared minus 4. I see that that's of this form. I'm instructed to make this substitution, and that's what I just did. Let's see how it works out. So that means the du is 2, okay, what's the derivative of the secant? Secant tangent. So du is twice secant theta tangent theta. And u squared minus 4 is, here's the payoff. I'm supposed to be able to rewrite that in terms of the tangent, according to this. U squared minus 4 is 4 secant squared minus 4, and secant squared minus 1 is tangent squared. So this is 4 times the tangent squared of theta. Right? Yeah? But I squared it. And now I'll square root it, and I'll get a 2, and this tangent will go away. So there's my data box for this substitution. And let's go on to another board. So where I'm at is the integral of du over the square root of u squared minus 4. And I have all the data I need here to rewrite that in terms of theta. So du is 2 secant theta tangent theta d theta. And the denominator is twice the tangent of theta. Ha! Well, so some very nice simplification happens here. The 2's cancel, and the tangents cancel, and I'm left with trying to work with the integral of the secant of theta, d theta. And luckily enough, at the very beginning of the hour, I worked out how to compute the integral of the secant of theta, and there it is. So this is the natural logarithm of the secant of theta plus the tangent of theta plus a constant. And we're done with the calculus part. There's no more integral there, but I still am not quite done with the problem because, again, I have these 2 substitutions to try to undo. So let's undo them one by one. Let's see. I have this trig substitution here, and I could use my triangle trick if I need to, but maybe I don't need to. Let's see. Do I know what the secant of theta is in terms of u? Well, I do. So I get the natural logarithm of u over 2. Do I know what the tangent is in terms of u? Well, I do. It's here. So I lucked out in this case, and I don't have to go through and use that triangle trick. So the tangent of theta is the square root of u squared minus 4 over 2. Good. So I've undone this trig substitution. I'm not quite done yet because my answer is involved with u, and what I wanted originally was x. But this direct substitution that I started with is real easy to deal with. I can just put x plus 2 every time I see a u. And so this is the natural logarithm of x plus 2 over 2 plus the square root. What's going to happen when I put x plus 2 in place for u here? You know what you get. You get exactly what we started with, right? If I put x plus 2 in place of the u here, I get x squared plus 4x. So I've gotten back to a function purely in terms of x. Okay, that's a good place to quit. Have a great little one-day break. I guess this class doesn't meet on Monday anyway, but